now we're going to move to ISLM BP model. So just like we did with ISLM model, let's go equation by equation. So let's start with IS curve. Okay, so we have following set of simultaneous equations. First we have equilibrium condition, just like before. Aggregated expenditures are defined as consumption as a function of disposable income plus investment as a function of interest rate, exogenously given government spending, and current account as a function of income and exchange rate. Okay, just like before, derivative of consumption with respect to disposable income, denoted as C prime, is marginal propensity to consume, and is somewhere between 0 and 1. In derivative of investment with respect to interest rate, just as before, is denoted as A prime, I prime, is negative. The bigger the interest rate, the lower the investment. The two new things that appear over here are the derivatives of current account. But look, just as before, we deal with this. We deal with those two derivatives in case of implicit function rule for one equation. So we should remember that derivative of current account with respect to income, which we will denote as CAY, which is simply NPC, and it is negative. Well, we could say even more that it is somewhere between -1 and 0, but it's not necessary. All we need to know for now is that this is negative. Then we've got the derivative of current account with respect to exchange rate, and remember, exchange rate is defined how many units of our currency we need to pay for 1 unit of foreign currency, which means that when E goes up, our currency depreciates, and when our currency depreciates, current account improves because our exports become more competitive. Okay, then to complete the model, we have the disposable income is defined as income minus taxation, and taxation is a function of income in a way that derivative of taxation with respect to income, denoted by T prime, is somewhere between 0 and 1. Okay, here there's one important derivative for us to remember. This is derivative of consumption with respect to income, and we calculate it using the chain rule, because this is dc dyd times dy dy. This is of course NPC, and now disposable income differentiated with respect to income, we get 1 minus T prime. Okay, now knowing this, we are ready to calculate the slope of IS. In order to do so, first we condense the entire model into one equation, which in this case basically means combining those two. And let's just move all the okay, so we get that this is y equals c y d plus I plus g 0 plus c a y e. Let's move all the endogenous variables to expressions with endogenous variables to the left-hand side. So we've got y minus c y d minus I minus c a y e equals to g 0. Now, of course, to find the slope, we need to differentiate this equation with respect to income and interest rate. Okay, look. Out of this, we're getting dy out of this one. C prime 1 minus t prime dy. Here we will have I prime di and minus c-a-y dy. It's equal to 0. Now, let's collect all the expressions with y's together. So we get 1 minus c prime 1 minus t prime minus c-a-y dy minus I prime di equals to 0. Now, let's move dy to the other hand side of the expression with dy to the other hand side of the equation. And now let's divide both sides by dy and negative I prime. Minuses cancel each other out. So this is clearly negative. This is between 0 and 1. This expression MPC in this case is that. So this one I'm sorry, MPI with a minus. This expression is negative. It has minus up front. So this is clearly positive. The denominator is negative. So this must be negative. This is how we get, again, the slope of IS in open economy with general function is still negative. Okay, now let's move to LN curve. And this is very easy, the same as in case of closed economy. We've got money demand that is given by L, Y. And we remember that derivative of L with respect to Y, which is equal, which we denote Ly, is bigger than 0, and derivative of money demand with respect to interest rate, Li, is lower than 0. So the higher the income, the more money we need, the higher the interest rate, the higher is the opportunity cost of holding money, so lower the money demand. Then, money supply is given exogenously by central bank, and equilibrium condition is money demand equals money supply. Now, to find the slope of Ln, again, all we need to do is to condense the equations. In this case, all expressions with endogenous variables are on the left, and then differentiate it with respect to y and I. We get this as Ly dy equals to plus Li di equals to 0. Now, we move this part, expression with y, to the other hand side of the equation. Now we divide both sides by Li and dy to obtain that di dy is equal to negative Ly Li. Ly is positive, Li is negative with a minus. The slope of Ln must be positive. And finally, we've got the BP curve. Okay, here BP curve, we have current account as a function of income and exchange rate plus capital account. We will be denoting capital account simply by K. And this is a function of domestic interest rate and interest rate in the rest of the world. And of course this needs to be equal to 0 like we discussed before. This is the equation representing demand and supply for currency. Okay, now here we need to have two derivatives. Partial derivative of k with respect to I, which we will denote ki, is positive. Look, the higher the interest rate in our country, the higher is the capital inflow, so the better is the position of capital account. On the other hand, derivative of capital account with respect to world interest rate need to be negative because the higher is the interest rate in the rest of the world. Of course, keeping our interest rate constant, the higher is the outflow and the worse position of capital account. Okay, again, in order to find the slope of BP curve, we need to differentiate this equation with respect to income and interest rate. So we get that this is CAYDY plus KIDI equals to 0. We do the same steps. We take these equations, expression with y, we put them on the left hand side. So we got KIDI equals to CA minus CAY dy. And now dividing both sides by dy, KI, we get the dy is equal to negative CAY over KI. CAY is negative, we have minus up front, KI is positive. So we get that the slope of BP curve is positive. Okay, so now we have the system of three simultaneous equations. So let's put them together and make sure that this system has a solution. So we will use implicit function theorem for the case of three functions. So look, our function number one goes like this. First, we have three endogenous variables: y, interest rate, income interest rate, and exchange rate. And then we will have three exogenous variables: government spending, money supply, and world interest rate. Okay, so first we go through IS equation. So already moving everything to the left hand side, we got that this is y minus cy d minus I of I minus g0 minus CA y e equals to 0. Then we need equation for ln. So this is L y e minus m 0 equals to 0. And finally, equation for BP, which we don't even have to change even slightly. we want to know if this system of three simultaneous equations implies y, e, and e, I and e as a function of g0, m0, and iw. In order to accomplish that, we need to calculate the Jacobian for this system of three simultaneous equations. Okay, so look, again, let's just do it step by step. So remember, we start with the first equation, and we first differentiate f with respect to income, then we differentiate f with respect to interest rate, f1, and then with respect to exchange rate. We do the same thing for the second equation, so we differentiate with respect to income, differentiate with respect to interest rate, and we differentiate with respect to exchange rate. And finally, we do the same thing with the third equation. We differentiate with respect to income, we differentiate with respect to interest rate, and we differentiate it with respect to exchange rate. So, now what can we do is to calculate those derivatives. And look, okay, let's start over here. Here we have derivative of y is 1. If I differentiate this with respect to y, I'm going to get minus c prime 1 minus t prime. Then y doesn't appear anywhere except here, and this is simply negative minus c a y. Then I differentiate the same equation. Let's do it like this because it's better to keep things here clear. Okay. So now I differentiate the second equation. I can just get ly, and the third equation again ca y. Now I differentiate all three equations with respect to interest rate. So I get negative I prime. From here, Li, and from here, Ki. And then to exchange rate. Here I get negative CAE. Here, 0, no expression with exchange rate. And here, CAE. Okay, look, what I'm going to do in the next step is that I'm going to take a common element out of the last column, which is CAE. Then we get 1 minus C prime, 1 minus T prime, minus CAY, LY, CAY, minus I prime, LI, KI, negative 1, 0, 1. Now, the best way to solve it is with the Laplace expansion. I'm going to choose the last column because it's the easiest. And look, so over here, I'm going to start with CAE. Now I'm opening brackets, and I've got negative, because first row, fourth column element is negative 1, so we've got minus, and over here what appears is LY, CAY, LI, KI. And then for the last element, for 1, I'm just having 1 minus C prime, 1 minus T prime, minus CAY, LY, minus I prime, LI. Okay, I'm closing the brackets. And what am I getting here? CAE. And now, out of the first determinant, I'm getting negative LY, KI, plus LICAY. And out of the second determinant, I get 1 minus C prime, 1 minus T prime, minus CAY. I want to fit it here, I'm sorry, minus CAY Li and plus Ly I prime. Okay, and now look. Here we have LICAY with plus. Here we have LICAY with minus. So they cancel each other out. And now I can just collect those elements and I'm obtaining the final solution. So, what we get is that this is positive, this is between 0 and 1, this is, I'm sorry, Li is clearly negative, Ly is positive, and I prime is negative. So, negative and negative, their sum must be negative, multiplied by a positive number. This is clearly negative. And if this is clearly negative, it means that it's definitely different than 0. And if it's different than 0, the conditions of the implicit function theorem for a system of simultaneous equations is fulfilled. And if it's fulfilled, then we can write that those equations imply y as a function of g0, m0, and iw, I as a function of g0, m0, and iw, and finally e as a function of g0, m0, iw, in the, of course, in the neighborhood of equilibrium of this system. Okay, now, because we know that this system has a solution, now we can using the implicit function rule, we can calculate its comparative static derivatives. Okay, but let's go step by step. Now that we know that those equilibrium values exist, let's transform this system of 3 simultaneous equations. Okay, we can write it, so we've got, and let's do it like this. Let's put all exogenous variables to the right, okay, slow. First, let's transform it. So we've got y minus yd minus I equilibrium minus CA I, sorry, my time is running out, then Ly I minus, oh, and I forgot here about G0 minus G0 minus CAY equals to 0, and finally CAY plus KIW equals to 0. Now, we're going to calculate total differential of this system, and we can already organize it. Because, we will have expressions like in the Jacobian, right? So we will have here 1 minus C prime, 1 minus T prime, minus CAY times dy, then minus I prime di minus CAE dE. And the last thing that we didn't have there is exogenously given G0, which we will move to the other hand side of the equation, the last differential. Now we do the same for the second equation. We've got Ly dy plus Li di, and now we move to the other hand side, dm0. Okay, and finally, from the last equation, we get Cay dy plus Ki di, and plus Cae de. And this is equal to, and look, out of this, differentiating this would give us Kiw times Iw. We move it to the other hand side of the equation. Okay, and finally, we can take this system and we can put it into matrix notation. So look, what we have found over here is that this system has a solution, and we know it's Jacobian. We will be able now to calculate its comparative static derivatives. And we will do this in the next part. Thank you for your attention. Wait. Actually, I still have 3 minutes, which I didn't expect. So let's just make one additional, let's say one additional thing. Look, at this moment, we have established a couple of things that will help us with the graph of the model. Okay, look, firstly, we've learned that the slope of IS is negative, that the slope of LM is positive, and that the slope of BP is also positive. But because the Jacobian did not vanish, so Jacobian is equal to is different than 0, we can be sure that equilibrium solutions do exist. Okay, and in the next video, we are going to analyze the impact of monetary and then fiscal policy on equilibrium income, interest rate, and exchange rate in the model. Okay, now thank you for your attention.